Tonight, we will drift into a story that hovers between science and mystery, a story that begins not in some distant galaxy, but here, within our own solar neighbourhood. In recent years, a handful of strange visitors have passed through our skies, moving on paths that seem too precise, too improbable, to belong only to chance. Some astronomers call them comets, or fragments of lost worlds, shards of rock and ice that wandered for millions of years before arriving here. Yet others whisper of possibilities more unsettling, that they could be messages, scouts, or even silent machines sent by minds older than our own. The truth remains unsettled, like a faint star on the horizon that flickers but never disappears. What matters tonight is not certainty, but the wonder of the question. As we follow these wanderers, Oumuamua, Borisov, and the newest atlas, we will not seek to prove or to deny, but to listen as one listens to a voice carried by the wind, unsure from where it came or what it means. This is Arcane Skies. If these journeys through mystery bring you calm, a gentle like or subscription would mean the world. And if you wish, share in the comments where and when you are listening, so that together we may map our small lights beneath the vast canopy of stars. Long before telescopes stretched our vision across the void, humanity's eyes searched the heavens with nothing more than wonder. The first philosophers of Greece, gazing upward from stone courtyards and olive groves, spoke of celestial spheres moving in perfect harmony, each star pinned to a crystalline dome like jewels in a divine crown. In China, scholars kept meticulous records of comets and guest stars, believing them to be omens carried by the breath of dragons across the sky. And in ancient Mesopotamia, clay tablets recorded the nightly dance of planets, their motions thought to mirror the rise and fall of kingdoms. Across cultures and centuries, the stars were never silent. They were storytellers, and people learned to listen. Even as science replaced myth with measurement, the sense of awe remained. Galileo, pressing his eye to the first crude telescope, whispered at the sight of Jupiter's moons circling like a miniature solar system. Kepler struggled to describe planetary orbits not as perfect circles, but ellipses stretched like drawn bows, an idea that unsettled tradition yet fit the observations. Centuries later, the technology became more intricate, the lenses clearer, the computers faster, but the motivation stayed the same: to know what passes through the night, to capture with numbers and images what otherwise would slip away unseen. It was this same motivation, patient and almost devotional, that set the stage for one of the most bewildering discoveries of our age. By 2017, our instruments had grown capable of noticing objects far smaller and swifter than the comets that once dazzled naked eyes. Pan-STARRS, a powerful survey telescope perched on the volcanic heights of Hawaii, scanned the sky each night, hunting for near-Earth asteroids that might one day pose a threat. Its cameras worked tirelessly, snapping image after image of the deep night, comparing them with the previous ones, searching for the faintest pinprick that shifted in position. For years, this work was routine, almost monotonous, like listening for a whisper in a crowded room. Yet it was this routine vigilance that allowed humanity to glimpse something no one expected. On the 19th of October, an operator noticed a moving point of light that did not fit familiar patterns. It was not circling the sun in the calm, predictable loops of our planetary family. Its trajectory was steep, slicing through our system as if arriving from elsewhere, like a stranger stepping across a threshold uninvited. At first, data alone could not reveal the magnitude of the find. It was just another point among billions. But as calculations unfolded, the path grew stranger. The object was moving far too quickly to be bound by the sun's gravity. Whatever it was, it had come from beyond and would not return. Astronomers gave it a name drawn from Hawaiian language, for it was discovered on Hawaiian soil, Oumuamua. The word means scout, or messenger from afar arriving first. Even in the act of naming, a subtle poetry crept in, as though intuition sensed that this was no ordinary stone. Some heard in that word the faint echo of mythology, as if the heavens themselves had sent a herald. Others treated the name simply as a gesture of respect to the island culture. Yet regardless of interpretation, the name stuck, carrying with it the weight of mystery. For the scientists who watched, there was a mixture of exhilaration and unease. Imagine standing at the edge of an ancient forest and seeing a shadow move in the distance. Was it just a branch swaying, or something alive, aware, perhaps watching? Oumuamua was like that shadow, slipping quickly across the solar system, too distant to touch, yet close enough to disturb imagination. Its brightness flickered as it spun, suggesting a shape unlike anything catalogued before, where asteroids are usually roundish, battered by countless collisions, and comets wear their soft luminous veils. This object stretched thin and elongated. Some argued it resembled a cigar, long and narrow, tumbling end over end. Others proposed it might be flattened like a cosmic pancake. No telescope could capture more than a point of light, yet the way that light brightened and dimmed carried hidden clues. Ratios were calculated, 10 times longer than it was wide, more extreme than any natural body yet observed. It was as though nature had sculpted an object in defiance of her own rules. And then came the stranger detail still. As Oumuamua rounded the sun and began to recede, it accelerated. Objects follow predictable paths. Comets sometimes receive small nudges from jets of vapour boiling off their icy surfaces. But this visitor showed no tail, no haze, no whisper of dust. It simply moved faster, as though something invisible pushed upon it. Numbers did not lie. Charts showed the deviation. A collective shiver passed through the astronomical community. Whispers began. Could radiation pressure from sunlight be enough? Perhaps its surface was so thin, so reflective, that photons nudged it like wind on a sail. This suggestion recalled the dreams of engineers who had long imagined solar sails, vast, fragile sheets carrying probes across interstellar distances on the breath of starlight. If humans could imagine such a technology, might not others, older and more advanced, have built it? Of course, most resisted this leap. Science thrives on restraint, and extraordinary claims demand extraordinary proof. To label a distant object as alien technology was to step onto dangerous ground, risking reputation and credibility. Yet the data remained, stubborn and unexplained. To some, Oumuamua was a messenger of possibility. To others, it was a puzzle that would eventually yield a mundane solution. But before any resolution could be reached, the object slipped away, fading into the dark like a figure disappearing down a corridor. Humanity had caught a glimpse, nothing more. The story of this discovery is not simply one of astronomy, it is also one of human reaction. Wonder, skepticism, fear and curiosity swirled together like the colours of a sunset, hard to separate yet beautiful in their blending. For those who lay awake at night staring into the darkness, Oumuamua became more than a rock. It was a symbol, a reminder that the universe does not revolve around us, and that perhaps we are not the only watchers gazing out into the void. The summit of Haleakala rises above the ocean like an ancient guardian, a dormant volcano whose slopes are painted in rust and ash. On clear nights the air there grows thin and crisp, the stars piercingly sharp against a velvet dome. It was here, at this lonely height, that Pan-STARRS kept its vigil. The telescope's domes turned slowly, their great shutters opening like the eyelids of some mechanical creature awakening at dusk. Each night, under red safety lights that cast everything in a hushed glow, astronomers settled into their routines. Screens filled with rows of stars, each dot a memory of light that had travelled years, decades, centuries to arrive at this moment. The atmosphere hummed with the low whir of cooling fans and the occasional tap of keys. Routine is the backbone of astronomy. Most nights bring nothing more than confirmation, objects exactly where calculations predict them to be. The satisfaction comes not from surprise but from precision, the quiet assurance that the universe is obeying the rules it has always followed. Yet within that monotony lies the thrill, the chance that one night, amidst the patterns, something will refuse to fit. That night in October 2017 began like countless others. Images scrolled across the monitors, familiar star fields blinking in and out. Software compared them against reference maps, flagging anything that shifted position. An asteroid passing near Earth, perhaps, or a faint comet awakening under the sun's warmth. But one particular streak of light caught the attention of an observer. Its movement was faster, its angle sharper. The numbers did not suggest a familiar orbit. Curiosity sparked. Files were checked again, measurements recalibrated. Yet the conclusion only grew stranger. This object was not bound to the sun. The realization unfolded gradually, like a dawn where the horizon glows long before the sun itself appears. Data from subsequent nights confirmed it. The intruder was already arcing away, racing through on a trajectory that no local body could follow. Word spread quickly through the small, tight-knit world of astronomy. Phones buzzed, emails flew, observatories in other hemispheres turned their gaze. The race began, not against time alone, but against distance. Oumuamua was moving fast, too fast for hesitation. Every hour meant fewer photons to gather, less chance to uncover its secrets. Within the control room, the atmosphere shifted. The quiet hum of routine gave way to the electric tension of discovery. Astronomers who had spent years scanning the sky for near-Earth objects now found themselves guardians of a message from beyond. Conversations quickened, filled with technical shorthand and bursts of disbelief. Coffee cups were refilled, shoulders hunched toward screens. No one wanted to miss even a single data point. But outside, on the slopes of Haleakala, the world continued indifferent. The trade winds whispered through grasses, the ocean shimmered faintly far below, and above it all stars wheeled silently on their ancient paths. The volcano had seen centuries of comets sweep past, countless meteors burn in the atmosphere, but it had never hosted a night like this. Humanity, for the first time, was witnessing a confirmed traveller from another star system, and it was unfolding in real time under the cold brilliance of the Hawaiian sky. The discovery drew minds far beyond the island. In Europe, Asia, and the Americas, telescopes joined the chase. Each new observation added strokes to a portrait that grew stranger with every line. Its brightness rose and fell in ways no ordinary asteroid displayed. Its speed, its path, its lack of any visible tail, all unsettled assumptions. The word alien was not spoken aloud in press releases or official papers, yet it flickered in late-night conversations, in the quiet musings of scientists who knew how unusual this was. For those working the instruments that first week, there was also a deeply personal awareness. They were the first humans to glimpse something that had wandered for millions of years through the interstellar deep. Perhaps it had passed by other suns, seen planets circling other skies, endured radiation storms and cosmic collisions, and still it survived to flash briefly through our own backyard. And they had been the ones to catch it. That knowledge settled into them like a secret, thrilling and humbling all at once. Yet for all the data gathered, the telescope could only reduce Oumuamua to a point of shifting light. No photograph would show its shape clearly, no probe could be launched in time to meet it. The story would be told through graphs and calculations, flickers of brightness plotted across nights. In those tiny fluctuations, astronomers read the possibility of a cigar-like form, or perhaps a flattened shard. They read rotation, tumbling like a forgotten relic spinning endlessly in the void. They read a past that began somewhere beyond the nearest stars, though where exactly no one could say. In the midst of this frenzy, a strange calm occasionally descended. An astronomer might step outside for air, feel the cold wind sweep across the mountain, and look up with naked eyes. There, above the dome, lay the Milky Way stretched in its band of silver, serene and timeless. Somewhere among those countless suns, Oumuamua had been born. The thought was both comforting and unsettling. Comforting because it reminded them of continuity, unsettling because it suggested vast unknowns. It is easy to imagine that night as cinematic, the control room buzzing with tension, the sky outside eternal. Yet what makes it remarkable is not drama, but subtlety. The discovery was not heralded by flashing lights or thunderous signs, but by a faint pixel shift on a monitor. A small point of light behaving differently than expected. The universe often announces its wonders not with spectacle, but with whispers that only the patient can hear. By the time the world's media caught on, the astronomers had already spent sleepless nights calculating, confirming, debating. Headlines shouted about alien visitors, cosmic cigars, messengers from afar. But within the scientific community the tone was quieter, a mixture of pride and unease. They knew how little time remained. The object was fleeing, and humanity had nothing fast enough to pursue. All they could do was observe, record, and wonder. And so the night of discovery bled into the next and the next. The world below continued as always. Cars moving through city streets, tides rising and falling, people dreaming of ordinary things, while above, a solitary traveller slipped silently away. Those who had first seen it would remember not just the data, but the feeling. the sudden awareness that the cosmos had spoken in a language we barely understood. A message had passed by, and for once we were listening. When astronomers traced the path of the visitor, the numbers revealed something extraordinary. Most objects that drift through our solar system are tethered to the sun by invisible threads of gravity. They circle in ellipses, some neat and compact like the orbits of planets, others stretched and wandering like the comets that spend centuries in darkness before flaring briefly in the light. But the path of Oumuamua was not an ellipse at all. It was a hyperbola, an open curve that told a very different story. This traveller had not been born here, and it would never return. To picture a hyperbola, one might imagine throwing a stone from the bottom of a well. Most stones rise, pause, and fall back down, pulled by the weight of Earth. Only if thrown with immense force will a stone leave the well entirely, arcing upward and never descending again. Our sun is a cosmic well, and nearly everything within it, planets, asteroids, comets, remains bound, circling endlessly inside its pull. Oumuamua, however, was a stone thrown hard enough to escape, a stranger from beyond who happened to fall across our sight line. This realization sparked awe and unease in equal measure. For centuries, astronomers had speculated about whether fragments from other star systems might drift into ours. Theorists suggested that newborn planets around distant suns might fling debris outward during their violent youth, scattering shards of rock and ice into the galaxy like sparks from a forge. But until this moment, such fragments had remained hypothetical, ideas scribbled in papers but never observed. And now, before the eyes of a generation, here was proof. Interstellar wanderers did exist, and one had come close enough for us to glimpse. As calculations grew more precise, the strangeness deepened. Oumuamua's speed exceeded anything expected for an ordinary object. Nearly 200,000 miles per hour carried it past the sun, past the Earth, and out toward the edges of the solar system. Even as astronomers adjusted for gravitational pulls, the numbers held. This was no comet lazily circling home. This was a messenger hurtling with purpose, as if aimed by some distant hand. Metaphors blossomed in the minds of those who studied the graphs. Some imagined a cosmic arrow, loosed from a bow drawn far beyond our stars. Others compared it to a seed blown on the galactic wind, landing briefly in our soil before drifting onward. The truth was unknowable, yet the imagery clung to memory, giving shape to what the numbers alone could not convey. Still, science demanded caution. A hyperbolic path did not automatically mean design. Natural mechanics could fling an object across space, just as rivers fling pebbles onto unexpected shores. Yet the improbability lingered. The odds of such an encounter in a human lifetime were vanishingly small, and yet here it was, unfolding before us. Telescopes across the world scrambled to keep up. Each night mattered, for the object was already retreating into darkness. Observatories measured the angles, fed them into computers, and charted the curve that widened ever outward. The hyperbola traced not just a path but a destiny. Never again would Oumuamua pass this way. Humanity's glimpse was fleeting, a brush with the infinite that would not repeat. For those who listened to the data, the experience was almost philosophical. Here was a visitor that had travelled perhaps millions of years through silent gulfs, never once touched by recognition, until in the brief blink of a century it slipped past a species newly able to notice. It was as if the universe had tested us. Are you watching yet? Can you see what moves among the stars? The hyperbolic trajectory also stirred deeper questions. If this was only the first such object we had observed, how many more had passed unseen, gliding silently through the outer dark before our telescopes were sharp enough to notice? Perhaps the galaxy was littered with them, stones from other cradles of creation, each bearing clues to worlds we might never otherwise know. Some scientists spoke of interstellar archaeology, the idea that by studying such visitors we might glimpse the conditions of faraway systems, like shards of pottery washed ashore from a city drowned long ago. But Oumuamua was not pottery. It was more enigmatic, its path too sharp, its form too strange. To some, the hyperbola looked less like the scatter of debris and more like intention. And though scientists were careful with their words, imagination strayed. In quiet corners, after the press conferences ended, questions hovered. What if it was aimed? What if the hyperbola was not chance but choice? In the language of bedtime reflection, It mattered less whether the answer was natural or not. What mattered was the feeling it inspired. To know that our solar system is not a sealed vault but a crossroads, that travellers may pass through carrying tales of distant stars, changes the way we see the night sky. Each star becomes not just a light but a potential birthplace, each darkness a corridor through which something unseen might already be travelling. And so the hyperbola of Oumuamua, traced on chalkboards and glowing on computer screens, became more than geometry. It became a story arc, one that began in some unknown cradle, arced through our presence for a heartbeat, and vanished toward the beyond. In its curve was written both a departure and a reminder. The universe is not empty, and our nights are not solitary. As Oumuamua faded from sight, its path remained etched in memory, a line drawn across the solar system's map like the fleeting stroke of a brush. For those who study the heavens, it was both a triumph and a sorrow. Triumph in finally glimpsing what theory had long predicted, sorrow in knowing the story was incomplete, the answers forever beyond reach. But perhaps, they told themselves, this was only the beginning. For where one traveller had appeared, others surely followed, and with them new hyperbolas, new stories, and new mysteries. When the first observations of Oumuamua's brightness were charted over time, the pattern looked like the heartbeat of something restless. The light would swell, then fade, then swell again, as though the object were turning, showing first a broad side, then a narrow edge, then broad again. From such variations, astronomers could deduce what their eyes could not see. The shape was not rounded, not familiar, but stretched in a way that defied expectation. Asteroids in our solar system are scarred lumps, battered into irregularity by endless collisions, but even their extremes remain within a narrow range. The longest among them are perhaps 3 times their width. Oumuamua, however, seemed to push far beyond. Calculations suggested it was 10 times longer than it was wide, perhaps even more. Imagine a cosmic splinter, elongated and thin, tumbling end over end like a baton tossed in the air. Others argued it might be pancake flat, broad and thin like a shard of mica, or a leaf adrift on invisible currents. The truth eluded certainty, for no telescope could resolve it beyond a pixel of light. Yet whether cigar or pancake, the conclusion was the same. Nothing like this had been seen before. For the astronomers, such a form was troubling because natural processes tend toward the familiar. Gravity pulls matter into spheres, collisions fracture bodies into chunks. Extreme elongation requires either improbable chance or forces not yet understood. Some tried to imagine an ancient fragment torn from the surface of a planet, sheared into a shape no one had envisioned. Others suggested icy shards formed in distant systems, where conditions bent different rules. Still others admitted quietly that it looked engineered, like something designed for efficiency in travel. The image of a cosmic cigar caught popular imagination, easy to visualize, striking in its oddity. Artists sketched long, shadowed forms sliding through the stars, their surfaces coloured in metallic reds and deep browns. Yet the pancake model had its allure too, a flattened disc broad enough to catch the push of light itself, turning gently as it sailed. Both metaphors carried human resonance, for cigars and pancakes are objects of daily life, tangible and mundane. And yet here, in the black vastness, they became uncanny, familiar forms rendered alien by scale and context. In quieter moments, some astronomers admitted the shape gave them chills, not because it suggested visitors, though that thought hovered in the background, but because it revealed how much the universe still withheld. To encounter something that broke the mould so completely was to be reminded of our ignorance, of the countless pathways matter might take in conditions beyond our imagining. To look upon Oumuamua was to peer into a gallery where nature displayed an art we had not known she could create. The object's rotation added to the mystery. Instead of spinning smoothly like a balance top, it tumbled chaotically, as if thrown carelessly into the void. Each turn altered the glint of sunlight, giving astronomers their only clues. They plotted the changes, translated them into ratios, and emerged with sketches of extremes. And yet even these sketches were arguments, contested interpretations of a story written in light too faint to resolve. To the public, the descriptions carried an otherworldly allure. Headlines spoke of alien space cigars, fueling speculation that the object was not natural at all. Some readers imagined a derelict ship scarred by time, drifting silently across systems. Others conjured sails unfurling invisibly, carrying it from star to star. The truth was less dramatic, but no less profound. Whatever it was, its shape did not fit into the categories we had trusted. Scientists trained to resist leaps of imagination responded with caution, but even within their careful language, a sense of astonishment lingered. Terms like unprecedented elongation and physically implausible betrayed the depth of their surprise. And for those outside the discipline, it was enough to let imagination wander. What if it were a relic of a civilization long gone, a fragment of a structure built for purposes unknown? What if it were designed to tumble, to disguise itself as debris while travelling on silent errands? These questions were not conclusions, merely the whispers of possibility. Yet they found fertile soil in a public eager for wonder, for reminders that the universe remained vast and strange. The elongated form of Oumuamua became a mirror in which people saw their hopes and fears, the hope of not being alone, the fear of what other presences might mean. In bedtime silence, the object could be imagined as a spear cast across the galaxy, aimed without care for where it might land, or as a raft, carrying invisible passengers through gulfs of time, or as a shard broken from a world we will never know, carrying within it the memory of a sun not our own. Each metaphor added layers to the mystery, none closer to truth, yet all part of the spell it cast. Perhaps what unsettled most was not the possibility of design, but the reminder that the universe is not obliged to conform to our expectations. For centuries, we have catalogued and classified, reducing the heavens to charts and laws, and then, suddenly, a shape arrived that broke the template, refusing to be neat. It was like discovering a word in a language thought complete, a syllable that hinted at dialects never heard. As Oumuamua receded, its form remained uncertain, preserved only in the light curves and the arguments they spawned. The images left to us were interpretations, shadows cast by math upon imagination. Yet in those shadows lay a lesson, that the universe still holds the power to surprise, to upend assumptions, to remind us that our knowledge, however vast, remains a candle flickering in an endless night. And so the shape of Oumuamua, whether cigar or pancake, shard or sail, became not just a question of astrophysics but a story for all of us. It was a reminder that what passes through the night sky can be stranger than myth, that sometimes reality whispers tales more daring than fiction. In the end, the exact shape may not matter. What matters is the way it made us feel, curious, small, awake beneath the stars. As Oumuamua curved around the sun and began to drift outward, astronomers prepared to close their notebooks with a kind of resignation. The object had startled them with its sudden arrival, bewildered them with its shape, but surely now it would obey the predictable rules of motion as it departed. That is the comfort of celestial mechanics. Planets trace their paths with the precision of clockwork. Comets flare and fade according to laws well rehearsed. Yet this traveller refused to leave quietly. Numbers began to misbehave. The projected trajectory did not match the observed. Oumuamua was accelerating. The deviation was small at first, subtle enough to tempt dismissal as error, but night after night the data persisted. Observatories across the globe compared notes, and the pattern sharpened into certainty. It was moving faster than gravity alone could explain, as if some unseen hand pressed lightly against its back. This realization spread unease through the community. For astronomers, trust in the clockwork of the cosmos is nearly sacred. When something violates it, even by a fraction, it feels as though a familiar song has slipped out of key. The most obvious explanation was outgassing. Comets, after all, accelerate when jets of vapor erupt from their icy surfaces like invisible thrusters. Heat from the sun transforms buried ice into gas, which bursts forth, carrying dust and pushing the comet gently in the opposite direction. Astronomers know this well. It is why comets sprout tails that shimmer like banners in the night. But Oumuamua betrayed no such signs. No luminous tail streamed behind it. No halo of dust blurred its form. The telescopes revealed only the bare point of light, unaccompanied and unadorned. If outgassing was occurring, it was hiding its evidence with unusual skill. Speculation unfolded like branches from a trunk. Perhaps it was made of unusual ice, hydrogen or nitrogen, which would evaporate invisibly. Yet such materials are fragile, and the journey through interstellar space would likely have destroyed them long ago. Others proposed that its surface was coated in something dark, masking any emissions. But this too strained credulity. Each proposed explanation fit one piece of the puzzle, while leaving the rest unsolved. And so the mystery deepened. The numbers demanded an answer, but the sky offered none. Into that silence stepped imagination. A solar sail suggested some, a thin sheet of material so light that photons from the sun could push it forward. On Earth, the idea had long been sketched in the pages of engineering journals, even tested in miniature. If humanity could conceive of sails for starlight, might another civilization not have built one, long ago, and sent it drifting between the suns? This proposal, voiced publicly by Avi Loeb and his colleague, stirred both fascination and controversy. The suggestion that Oumuamua might be artificial, a relic, a probe, a piece of technology, was received by some as daring insight, by others as reckless speculation. The halls of academia grew suddenly loud with debate. Critics argued that natural explanations, however strained, must be exhausted before whispering of alien design. Supporters countered that science must remain open even to unsettling possibilities. The conversation spilled into newspapers, magazines, television screens. For a brief moment, a tumbling shard of interstellar debris became the most famous object in the heavens. Outside the academic circles, the story resonated on a deeper level. Ordinary people, far from observatories, heard of the mysterious visitor that had sped away with inexplicable grace. Around dinner tables and in late-night conversations, they asked the questions that science itself had not resolved. Could it have been a message, a derelict ship, or simply a stone playing tricks on our instruments? The uncertainty itself became a kind of wonder. The acceleration haunted astronomers because it broke the rhythm of predictability. If it had slowed as expected, its departure would have been a curiosity, nothing more. But to accelerate was to suggest hidden forces, unseen processes, perhaps even intention. It was like watching a leaf on a pond suddenly move against the current with no breeze to stir it. Instinct whispers that something unseen is at work. Yet for all the speculation, one truth remained sobering. We could do nothing but watch it vanish. Our spacecraft were too slow to catch it, our instruments too distant to pierce its secrets. It had swept past us quickly, offered a riddle, and was already slipping away into the dark. Humanity's encounter with its first interstellar visitor ended with a question mark trailing into infinity. In this sense, the acceleration became not just a physical puzzle, but a symbol. It reminded us of our limitations, of how young our technology still is, how small our grasp compared to the stage we inhabit. It whispered of mysteries beyond reach, daring us to imagine but denying us certainty. For scientists, this is both torment and inspiration. Torment in being unable to resolve the anomaly, inspiration in knowing the cosmos still contains questions worthy of pursuit. The tale of Oumuamua's acceleration does not end with an answer. It ends with possibilities, each shimmering like a mirage. Perhaps it was ice sublimating in ways we had never before observed. Perhaps it was a fragment of a world shattered in some alien catastrophe. Or perhaps, just perhaps, it was a relic of minds not our own, drifting silently across the gulf until chance, or fate, brought it close enough for us to notice. Whatever the truth, the object has already receded beyond the range of our gaze. It left behind no tail, no debris, no trace, but the memory of its passing and the numbers inscribed in our databases. Its acceleration is written in the equations, undeniable yet unexplained, like a single enigmatic line in a manuscript whose other pages are missing. And that perhaps is the most haunting part, that we were given only a fragment of a story, just enough to awaken curiosity, not enough to resolve it. For those who remember its brief sojourn, Oumuamua is no longer just an asteroid or a comet. It is a reminder that the universe does not yield its secrets easily. It is a lullaby of the unknown, a whispered challenge from the stars, urging us to keep watching, to keep wondering, to keep seeking the meaning behind the patterns that dance across our sky. The whisper that Oumuamua might not be natural began almost timidly, spoken in the corners of conferences and late-night emails between colleagues. But it was Avi Loeb, the Harvard astronomer known for his willingness to wander beyond the safe borders of consensus, who carried the idea into the open. He spoke of a solar sail, a sheet of material so thin and wide that sunlight itself could push it forward across interstellar distances. On Earth, engineers had long dreamed of such sails, envisioning craft propelled without fuel, drifting like ships before a cosmic wind. If humanity could imagine this, Loeb reasoned, then why should the idea be unthinkable for others? His words landed with the impact of a stone in still water. Ripples spread quickly, stirring fascination in some quarters and irritation in others. For many scientists, caution is a professional instinct. The universe offers countless puzzles, and extraordinary claims can mislead as often as they illuminate. To speak of alien technology, they warned, was to risk discredit, to encourage speculation unmoored from evidence. Yet Loeb countered that the evidence already defied natural explanation. Its trajectory, its shape, its silent acceleration, taken together, they hinted at design. Why should science fear the possibility, he asked, when curiosity is its lifeblood? The debate that followed was unlike anything astronomy had seen in decades. Journal articles dissected the claim, some rejecting it outright, others cautiously engaging with its details. Editorials appeared in newspapers, television anchors spoke of the alien space rock, and the public imagination ignited. For a brief season, Oumuamua became more than a scientific anomaly. It became a cultural symbol, a canvas onto which people painted their hopes and anxieties about the cosmos. Loeb's insistence did not come from a desire to shock, though critics accused him of courting attention. He framed his position as one of intellectual honesty. To him, the data demanded boldness. To assume natural explanations without considering alternatives was, in his eyes, a failure of imagination. Science, he argued, must follow evidence wherever it leads, even into uncomfortable terrain. In interviews, he spoke calmly, almost serenely, of the possibility that Oumuamua was artificial, perhaps a probe sent to drift through space as a beacon or a scout. Yet among his peers, skepticism hardened. Some proposed that Oumuamua could be a fragment of frozen nitrogen, chipped from the surface of a Pluto-like world in some distant system. Such a shard, sublimating invisibly, might account for the acceleration without leaving a visible tail. Others suggested hydrogen ice, though such material had never been observed in space. Each theory carried difficulties, yet defenders insisted it was better to wrestle with improbabilities than to leap to extraterrestrials. The clash revealed something profound about science itself, its balance between wonder and restraint. Scientists are trained to demand extraordinary proof before entertaining extraordinary claims. And yet history reminds us that discovery often comes to those willing to imagine beyond the known. Galileo dared to suggest Earth was not the centre, and Kepler dared to replace circles with ellipses. Each risked ridicule, and each reshaped the cosmos in human understanding. Loeb invoked this lineage, placing his argument within that tradition. Critics, however, reminded him that for every Galileo vindicated, there are countless dreamers whose speculations dissolved into error. In the wider world, the controversy was less about data and more about meaning. For ordinary listeners, the possibility of alien technology felt like an invitation to dream. What if the universe was not silent but filled with watchers? What if this shard of light passing briefly through our sky was a message, or a relic, or a signpost left by others who once roamed the stars? Even those who doubted found comfort in the idea. To imagine company in the cosmic dark is, for many, less frightening than solitude. The debate also exposed the fragile boundary between science and story. Numbers alone rarely move the heart, but the idea of a sail drifting on starlight, of a messenger arriving unannounced, resonates deeply. It is no wonder that journalists, artists, and filmmakers seized upon it, weaving Oumuamua into tales of contact and mystery. In those retellings, the visitor became almost mythic, a character in humanity's ongoing drama with the unknown. For the astronomers closest to the data, the experience was bittersweet. On the one hand, they welcomed the sudden attention to their field, the surge of curiosity among the public. On the other, they worried that the frenzy obscured the patient work of analysis. The truth, they knew, would not emerge from speculation alone but from the slow accumulation of evidence. Yet evidence was slipping away, receding into the dark with Oumuamua itself. The visitor had given only a fleeting glimpse, and now it was beyond reach. Still, Loeb's challenge lingered. Even those who rejected his conclusions admitted that Oumuamua had opened a door. If one interstellar object could arrive, surely more would follow. And when they did, perhaps we would be ready, with telescopes sharper, with probes quick enough to intercept. In that sense, the debate itself became a kind of preparation, forcing science to stretch its imagination, to ask not just what is probable, but what is possible. As Oumuamua's memory faded into archives and articles, the argument remained unresolved. To some, it was an icy shard behaving oddly. To others, it was a signpost pointing toward the presence of intelligence beyond our own. For everyone, it was a reminder that the universe still knows how to surprise us. The question was left open, as so many cosmic questions are, lingering like an echo that refuses to fade. And perhaps that in the end is the greatest gift of Oumuamua. Not an answer, but a question large enough to carry into the night. Was it natural or was it made? Was it chance or intention? The stars offered no reply, only silence and the faint light of possibilities. Yet in that silence, humanity found something it had always sought, the reminder that we are still children under a vast sky, listening for voices beyond the dark. Skepticism in science is not a wall but a filter. It is the net that catches falsehood before it hardens into truth. When Oumuamua's mystery spread beyond observatories into headlines and living rooms, that net grew tighter, for astronomers knew that the allure of alien technology was stronger than any sober explanation they might offer. And so the pushback began. At conferences, in journal articles, and in quiet conversations, researchers spoke with voices both firm and weary. To leap toward extraterrestrials, they said, was to abandon discipline. Nature is inventive enough without needing intelligence to explain its curiosities. They reminded audiences that comets had surprised us before. Some lacked visible tails, some fragmented unexpectedly, some glowed with colours no one had predicted. Why should Oumuamua be different? Theories multiplied like branches from a tree, a nitrogen iceberg chipped from the surface of a distant frozen world, a hydrogen block sublimating invisibly, a fragment of exotic ice unknown to our solar system. Each explanation carried its flaws, but together they formed a shield against the intrusion of alien speculation. The tone of this resistance varied. Some spoke with patience, careful not to extinguish curiosity but to guide it toward plausible paths. Others were sharper, dismissing the light sail hypothesis with a shrug or a laugh. In the halls of academia, reputation is currency, and many feared that entertaining alien technology would bankrupt their credibility. Better to risk an awkward theory of impossible ice than to risk being branded a dreamer. Yet ridicule carried its own danger. To the public, the quick dismissal of possibilities sometimes looked like arrogance. People who read headlines about alien probes and then saw scientists wave the idea away felt a tension between wonder and authority. Which voice should they trust? The cautious experts who insisted on restraint, or the daring few who spoke of sails and scouts? In that tension lay the heart of the drama. Science wrestling not only with data, but with its own image. The media, of course, favoured the spark. Stories about nitrogen shards did not travel far, but tales of mysterious visitors and alien sails spread like wildfire. Television anchors raised eyebrows, magazines illustrated Oumuamua as a gleaming craft, and podcasts whispered of secrets hidden in plain sight. Even those who doubted found themselves enthralled. To say probably a comet was to end the story. To say maybe a messenger was to invite 1,000 new chapters. Within the scientific community, this frustrated many. Astronomers accustomed to quiet obscurity suddenly found their field on centre stage, their data bent into shapes they barely recognised. Some resented Loeb for fanning the flames, accusing him of courting attention at the expense of rigour. Others admitted, if only privately, that the conversation had brought new energy, new eyes to the sky. Debate sharpened, funding proposals shifted, and the study of interstellar objects gained a momentum it had never known. Still, beneath the clash of voices, there was unity in one regard. Oumuamua had revealed how little we knew. Whether fragment or artifact, whether natural oddity or designed probe, it was the first of its kind observed. The very fact of its arrival meant the galaxy was more dynamic than we had dared to believe. If one such traveller had passed, countless others must be wandering the dark, unseen. For scientists of every persuasion, that realization was both humbling and invigorating. To those listening from the outside, the drama of skepticism and speculation mirrored a deeper human struggle. It is the balance between caution and wonder, between holding tightly to what is known and reaching for what might be. Too much caution, and we risk blindness to the extraordinary. Too much wonder, and we risk drowning in fantasy. Oumuamua became a mirror in which each person saw their own temperament reflected. Some saw only a rock, some saw a messenger, most saw both, hovering between doubt and hope. The ridicule, though, left a sting. Loeb's ideas were dissected in journals, mocked in whispers, even rejected by referees who refused to consider them seriously. He responded with defiance, publishing books and essays, speaking directly to the public. If his peers closed doors, he would open windows. This in turn deepened the divide, casting him as either a visionary or a provocateur, depending on one's perspective. The controversy was no longer just about Oumuamua, it was about the very boundaries of scientific imagination. Meanwhile, the object itself slipped further into the night, indifferent to the quarrels it had sparked. Beyond the reach of telescopes, it tumbled silently, carrying its secrets with it. The debates grew more abstract, less tethered to new data, more to interpretations of what little had been gathered. It was as though the visitor had thrown a riddle over its shoulder as it departed, leaving humanity to argue in its wake. And yet, even in their disagreements, scientists found themselves united in vigilance. No one wished to miss the next arrival. Observatories adjusted their surveys, algorithms were refined, telescopes poised to detect the faint streak of another interstellar traveller. If skepticism had hardened, it had also sharpened the tools of observation. In that sense, ridicule and wonder served the same master: curiosity. For the wider world, the lesson was gentler. Oumuamua reminded us that even experts do not hold all answers, that the sky can still throw mysteries too large for easy classification. It reminded us that science, like humanity itself, is a conversation, sometimes heated, sometimes hesitant, always unfinished. And it reminded us that skepticism, though sometimes sharp, is itself a form of faith, not in certainty, but in the slow unfolding of truth. In the end, the debates did not diminish Oumuamua's strangeness. If anything, they deepened it. For whether one chose the path of caution or the path of wonder, the fact remained. A traveller from beyond had passed through our system, behaving in ways we could not fully explain. The rest was interpretation, and interpretation is always coloured by human need. Some need reassurance, some need marvels, some need questions more than answers. And so the skepticism, the ridicule, the endless debate became part of the story itself. They revealed less about the object than about ourselves, about how we respond when the unknown brushes against our lives. For in truth, the universe did not pause to clarify, it simply moved on, leaving us to fill the silence with our own voices. The strangest thing about Oumuamua was how quickly it was gone. One moment it was the focus of every telescope on Earth, a luminous point whose data poured into spreadsheets and diagrams, and the next it was slipping into the outer dark, fainter with each passing night. No probe had been launched to chase it, no mission could catch such speed. We had been given a glimpse, nothing more, a brush of wings against the edge of awareness, and as it receded, a peculiar sorrow spread among those who had followed its flight. Astronomers are not strangers to loss. Comets disintegrate, stars fade, opportunities vanish with the turning of the sky. Yet, Oumuamua carried a different weight. It was the first of its kind, the first confirmed visitor from another star, and its departure felt like a door closing before we had time to cross the threshold. In observatories across the world, researchers stayed late into the night, watching the signal diminish until it was indistinguishable from background noise. They knew each number they recorded might be the last trace humanity would ever have of this messenger. Some described the feeling as akin to watching a ship vanish into fog, carrying secrets never to be revealed. Others compared it to a dream fading on waking, vivid, mysterious, and impossible to hold. The object left behind only questions, like footprints in sand already being erased by the tide. What was its true shape? Why did it accelerate? From what distant system had it come? All that remained were the faint echoes of starlight, curves on graphs, and the knowledge that we had not been ready. The public, too, sensed the poignancy. For a brief time, newspapers and television had spoken of Oumuamua as if it were a character in a story, a visitor with intentions we strained to decipher, and now the character had exited the stage without delivering a final line. In online forums and quiet conversations, people asked one another what they thought it had been. No one knew. That uncertainty became part of its legacy, turning it into a symbol of mystery rather than a solved equation. Among astronomers, the sorrow was mixed with resolve. They knew another interstellar object would come someday, and they were determined to be ready. Surveys were expanded, telescopes tuned for faster detection, proposals written for missions that might intercept such travellers in the future. In this way, the grief of loss transformed into a new hunger, a vow that the next time the universe sent a messenger, humanity would not simply watch it vanish. But the melancholy lingered. In the quiet after the debates, after the headlines faded, Oumuamua became a ghost. Astronomers who had worked long nights to capture its fleeting light confessed to dreaming of it, a shard tumbling endlessly in the void. Poets wrote of it as a wanderer, a scout, a relic. Musicians composed pieces inspired by its lonely flight. Even those who never looked through a telescope found themselves haunted by the thought. Something had passed through our solar system, something ancient and unknowable, and we had only seen its shadow. The image of loss was heightened by its very name. In Hawaiian, Oumuamua meant a messenger from afar arriving first. The word carried the sense of something that comes before others, a herald. If this was only the first, what might follow? Was it a warning, a sign, a mere accident of timing? The departure left these questions suspended in the air, like the last notes of a song that refuses to resolve. On the slopes of Haleakala, where it had first been noticed, the night sky remained unchanged. Stars wheeled overhead, the Milky Way arched in its silver band, and comets and asteroids continued their quiet circuits. But for those who remembered, the mountain felt different now. It had been the stage for a revelation, and though the visitor was gone, the silence it left behind was charged with significance. Some scientists comforted themselves with the thought that in a galaxy teeming with billions of stars, Oumuamua could not be unique. Others feared that such alignments were rarer than we imagined, that lifetimes might pass before another such messenger arrived. Both thoughts carried their own weight, one filled with anticipation, the other with melancholy. Either way, the night sky no longer seemed static. It was alive with possibility. For those who listened at bedtime, the story of Oumuamua's fading was a gentle reminder of impermanence. Just as dreams dissolve with waking, so too do cosmic visitors slip beyond reach. We are reminded that not all mysteries will be solved, that some are meant to remain as whispers, keeping alive the sense of wonder. And perhaps that is fitting. For if every secret of the stars were revealed, the night would lose its magic. And so Oumuamua departed, leaving behind no relics, no signals, no confirmation of its nature, only memory, only the knowledge that the universe is larger, stranger, and closer than we once believed. Its vanishing was not the end of the story, but the pause before a new chapter, an invitation to remain watchful, to wonder what else drifts through the darkness waiting to be seen. 2 years passed, and for many the story of Oumuamua had begun to soften into memory, a strange episode that lingered like a dream whose edges blur with time. The debates grew quieter, the headlines receded, but the sense of absence remained. Then, in the late summer of 2019, a new light appeared in the sky. One that would remind humanity that Oumuamua had not been a solitary anomaly, but perhaps the first note in a larger symphony. It was Gennady Borisov, an amateur astronomer in Crimea, who first noticed it. With a telescope of his own making, crafted by hand with the patience of a craftsman rather than the budget of a great observatory, he swept the skies and caught sight of a faint blur moving against the stars. To the trained eye it looked like a comet, fuzzy with a hint of a tail. Such discoveries are not unusual, but follow-up observations revealed something remarkable. Its orbit was not bound to the Sun. The curve was again hyperbolic, again declaring origin beyond our solar system. Humanity had its second interstellar visitor, named in honor of the man who found it, 2I Borisov. This time, the sense of astonishment was tempered with familiarity. The first interstellar object had shocked us because it looked so alien. Borisov, by contrast, looked entirely at home. Its coma of gas shone, its tail streamed in the sunlight, its behaviour matched that of comets catalogued for centuries. Where Oumuamua had been a riddle that defied categories, Borisov seemed to slide comfortably into them. For astronomers, this was both relief and revelation. Relief, because here was an interstellar object that behaved as theory had predicted. Revelation, because it proved beyond doubt that such visitors were not once-in-a-lifetime accidents. The galaxy was full of them, and our solar system was not a closed fortress but a crossroads. Images captured by the Hubble Space Telescope showed Borisov's tail stretching like a pale ribbon against the darkness. Spectra revealed cyanide and carbon monoxide, chemicals long familiar in the comets of our own system. It was as if a traveller from abroad had arrived speaking the same language as locals, wearing the same garments, blending into the crowd. Some scientists remarked that this familiarity was almost eerie, as though the cosmos had decided to reassure us after the confusion of Oumuamua. Others saw it as confirmation that planetary systems, wherever they form, produce the same raw ingredients, scattering them like seeds across the stars. The discovery of Borisov reignited interest in panspermia, the ancient idea that life itself might travel across the galaxy, hidden within such icy bodies. If comets could wander between systems carrying organics and water, then perhaps the building blocks of life were not confined to a single world but shared like pollen in a cosmic spring. Borisov, with its familiar chemistry and long, interstellar voyage, became a tangible example of this possibility. Scientists wrote papers, philosophers reflected on the universality of creation, and storytellers found new metaphors in its graceful tale. And yet, even in its familiarity, Borisov carried its own aura of mystery. Its nucleus, though small, glowed steadily even as it approached the sun, as if stubbornly holding itself together despite the forces that tore at it. Some fragments broke away, but the heart endured, shining until it finally receded into the distance. Unlike Oumuamua, which had vanished too quickly for detailed study, Borisov offered months of observation. It lingered long enough for the world to savour a second chance, a reminder that the first had not been an illusion. For many astronomers, Borisov was a balm. It restored faith in the ordinary, in the idea that nature, though surprising, was not incomprehensible. Papers were written with phrases like confirmation of theory and consistency with known cometary behaviour. The sharp debates that had raged over Oumuamua seemed to soften in its glow, and yet, in that very softness, a question remained. If Borisov was ordinary, then why had Oumuamua been so strange? If interstellar objects were meant to look like comets, why had the first one defied every expectation? The juxtaposition of the two visitors fascinated the public imagination. It was as though the universe had sent us first a riddle, then a reassurance. The first whisper said, "Things are stranger than you know." The second said, "Do not worry, the rules still hold." Together they painted a picture not of chaos but of variety, a reminder that the cosmos contains both the familiar and the uncanny, woven together in a fabric far richer than we once believed. Among the scientific community, Borisov strengthened the resolve to prepare for the future. If 2 visitors had arrived within 2 years, others must surely follow. New projects were funded, surveys accelerated, telescopes recalibrated to watch the skies with renewed vigilance. The hope was clear. The next time, we might be ready not only to observe but to reach, to send a spacecraft out to meet the messenger before it slipped away. For the dreamers, Borisov was proof that interstellar travel is not confined to science fiction. Not through ships or sails, but through the natural wanderings of icy fragments, crossing the gulfs of space with patient inevitability. To imagine that our solar system is bathed now and then by these ancient voyagers is to feel less alone, to sense that we live in a galaxy alive with movement, exchange, and hidden connections. And so, 2i Borisov came and went, not with the controversy of its predecessor, but with a quiet grace. Its tail shimmered in telescopes, its chemistry was catalogued, its orbit traced, and then it too receded into darkness. Yet unlike Oumuamua, it left behind a sense of completion. It had shown us what we expected to see, and in doing so it reassured us that the cosmos, though capable of wonder, still obeys patterns we can recognise. But in the hearts of many, the story of Borisov could not erase the ghost of Oumuamua. Instead, the two became companions in memory, one strange, one familiar, together sketching a portrait of the universe as both mysterious and comprehensible. They were the yin and yang of interstellar visitors, the cipher and the key, the anomaly and the confirmation, and in that pairing humanity found not answers but a widening horizon, a sense that the story was only beginning. When scientists placed the records of Oumuamua and Borisov side by side, it was as if the universe itself had painted two contrasting portraits. One was lean and silent, without tail or haze, slipping past in secret with only its peculiar acceleration to betray it. The other was bright and familiar, a comet in every sense, shedding gas and dust in the sunlight like countless others catalogued in human history. The contrast was so sharp it seemed almost deliberate, as though nature had chosen to remind us that variety is its signature. The comparisons began immediately. Oumuamua was tiny, perhaps only a few hundred meters long, tumbling chaotically in silence. Borisov was larger, nearly a kilometre across, and announced itself with a glowing coma and a broad tail. Oumuamua flashed through our system in mere weeks, leaving little time to study. Borisov lingered for months, allowing telescopes from Chile to Hawaii to orbiting Hubble to gather detailed data. Oumuamua provoked speculation of alien design. Borisov soothed that speculation by fitting neatly into the template of cometary behaviour. For astronomers, the pairing was instructive. They realised that interstellar visitors might not come in a single mould. Just as our own solar system produces both ordinary rocks and peculiar oddities, so too might the wider galaxy scatter forth objects of every conceivable form. Perhaps Oumuamua was not an outlier, but simply the first glimpse of a spectrum, a reminder that the universe's creativity far exceeds our categories. But for those outside the scientific community, the contrast felt almost narrative, like two characters in a story. Oumuamua was the enigmatic stranger who arrives unannounced, says nothing, and vanishes into the night, leaving whispers in its wake. Borisov was the open traveller, the one who shows his face, speaks plainly and reassures the crowd. Together they mirrored the human condition, our longing for mystery and our craving for certainty, our thrill at the unknown and our comfort in the familiar. The scientific debates reflected these dual impulses. With Borisov, researchers could ground their papers in chemical analyses, spectral signatures, and measurable quantities. They could speak with confidence of cyanide, carbon monoxide, and water ice. With Oumuamua, they had been forced to rely on inference and imagination, charting brightness curves and deviations that pointed toward, but never confirmed, the bizarre. In comparing the two, the contrast between data and mystery, between certainty and speculation, became stark. And yet the juxtaposition raised unsettling questions. If most interstellar objects resemble Borisov, why had the first one we saw been so anomalous? Was it simply coincidence, the luck of the draw, that the first guest was so strange? Or was Oumuamua a different kind of messenger, its oddities hinting at processes or designs we had not yet fathomed? The questions refused to fade, lingering like echoes even as Borisov reassured us with its conventional beauty. In quiet moments, some astronomers admitted that Borisov, though scientifically valuable, lacked the haunting allure of Oumuamua. To study Borisov was to work with familiarity, to confirm theories already held. To study Oumuamua had been to walk a tightrope over the abyss of the unknown. The former satisfied the intellect, the latter stirred the imagination. And perhaps, some mused, science needs both, the grounding of the known and the provocation of the mysterious. The public too sensed the contrast. Social media brimmed with comparisons, with artists painting Oumuamua as a shadowed shard and Borisov as a radiant comet. Writers described the two as twins of different temperaments, one dark and secretive, the other bright and open. Podcasts speculated that perhaps the galaxy had sent them in sequence, first a riddle to awaken us, then a reassurance to keep us calm. Though scientists cautioned against such anthropomorphism, the symbolism was irresistible. What the pairing truly revealed, however, was our own hunger for stories. We look at objects of ice and stone, and we see characters. We hear in their silence a dialogue, in their trajectories a plot. We are not content to let them be what they are. We must ask what they mean. In this way, the comparison of Oumuamua and Borisov became less about astrophysics and more about philosophy. They were mirrors reflecting our longing to find pattern and meaning in a cosmos that may, in truth, offer only chance. Yet perhaps chance itself carries meaning. If two interstellar objects arrived within 2 years, Perhaps the galaxy is more interconnected than we realized. Perhaps fragments are constantly crossing the gulfs, unnoticed until our instruments grew sharp enough to see them. If so, then each visitor is not a rare miracle, but part of a constant background hum, a quiet reminder that we are part of a larger whole. In that sense, the contrast between Oumuamua and Borisov was not contradiction but harmony. Together they showed that variety itself is the rule of creation. Still, the memory of Oumuamua's strangeness could not be erased. Borisov proved the ordinary, but the extraordinary had already passed. Like the memory of a dream, it lingered at the edges of thought, whispering that not everything has been explained, not everything fits the mould. The contrast, then, was not resolution but balance, the cosmos offering us both reassurance and mystery, as if to say, you will never run out of questions. And so the comparison became its own story. Scientists charted graphs, philosophers pondered meanings, and ordinary people gazed at the night sky with a renewed sense of wonder. Oumuamua and Borisov were not simply rocks tumbling through space. They were symbols, reminders that the universe can be both familiar and strange, that we can be comforted and unsettled at the same time. In the quiet hours when sleep draws near, their tale is almost like a parable. One visitor taught us that the cosmos still knows how to astonish. The other reminded us that patterns endure, that rules still apply. Between the two lies the truth of our existence. We live in a universe vast enough for both order and mystery, for both answers and questions. And that is why we keep looking up, night after night, listening for the next messenger who will cross our sky. After Borisov had faded into the deep black, telescopes folded their domes and astronomers exhaled. 2 interstellar visitors in 2 years was more than anyone had dared to hope, and yet the sudden bounty carried with it a peculiar tension. If these travellers were part of the natural rhythm of the galaxy, then surely there would be more. The question was not if, but when. And so began a waiting period, not empty of work, but charged with anticipation, like villagers scanning the horizon after seeing sails once appear on the sea. The world's observatories became watchtowers. In Chile's Atacama Desert, where the sky is so dry and clear that the Milky Way seems close enough to touch, instruments swept the heavens with renewed fervour. In Hawaii, Pan-STARRS and its kin continued their nightly vigil, recording the endless parade of stars searching for any subtle movement that might betray a passing visitor. In space, orbiting telescopes widened their gaze, sensitive not only to light but to the faintest chemical signatures. Everywhere there was a sense of readiness, as though humanity, chastened by how quickly Oumuamua had slipped away, refused to be caught unprepared a second time. In the months after Borisov, papers multiplied. Some modelled the expected frequency of such interstellar objects, calculating probabilities from planetary formation and gravitational scattering. Others proposed missions, spacecraft that could wait in readiness, engines primed to launch at a moment's notice when the next messenger appeared. Engineers sketched blueprints for probes that might chase down an interstellar visitor, intercept it, and even sample its material before it fled. It was as if the cosmos had issued a challenge, and humanity was determined to answer. Yet anticipation is not only technical, it is emotional. For those who had followed Oumuamua's riddles and Borisov's reassurance, the sky no longer felt the same. Each shooting star, each faint blur, carried the whisper, "Could this be another?" Ordinary comets seemed to wear the disguise of possibility. Amateur astronomers, sweeping the night with modest instruments, felt themselves part of a larger vigil, as though all humanity shared in a watch that stretched across hemispheres and generations. The waiting was not passive. Stories continued to circulate, not only in scientific circles but in the public imagination. Documentaries recounted the brief visits, novels imagined probes and messengers, artists painted interstellar ships disguised as shards of rock. The two objects had seeded a new mythos, one that blurred the line between fact and wonder. To wait for the third was to wait not just for another point of light, but for the continuation of a story already underway. In classrooms, professors spoke of interstellar objects not as speculation but as inevitability. Students heard of them as part of the living universe, like seasons or tides. Children asked teachers when the next one would arrive, as though it were a comet scheduled on a cosmic calendar. And in coffee shops, in late-night conversations, ordinary people spoke of Oumuamua and Borisov as if they were characters, enigmatic guests who had visited briefly and departed without farewell. Meanwhile, astronomers wrestled with the limits of readiness. To detect an object sooner required faster computers, broader surveys, sharper instruments. To intercept one required technologies not yet built, speeds not yet attained. The challenge loomed enormous, but so too did the motivation. For in the silence after Borisov there was a sense of inevitability. A third would come, and when it did, humanity hoped to meet it not as a bystander but as a participant. The waiting became almost ritualistic. Nights passed in observatories with little more than the steady clicking of shutters, the faint hum of cooling systems, the glow of screens filled with stars. Yet beneath the monotony was an awareness that at any moment a point of light could shift in ways no bound orbit could explain. That awareness gave each observation weight, as though the universe were holding its breath along with us. For some, the pause between visitors carried philosophical resonance. They reflected that perhaps the cosmos was teaching patience. Oumuamua had startled us, Borisov had steadied us, and now came the silence. A silence meant not to frustrate but to prepare. It was like the pause in music between movements, when the echo of one note fades and the ear strains for the next. In that quiet, humanity considered not only what might come, but what such encounters mean. The mythic frame returned again and again. Oumuamua the cipher, Borisov the confirmation. What would the third be? The herald, the revelation, the warning? Some imagined it as stranger still, carrying anomalies more baffling than the first. Others hoped for nothing more than another comet, reassuring in its ordinariness. Whatever it was, people sensed it would complete a kind of trilogy, though one written not in ink but in trajectories across the night. The anticipation grew sharper with each new season. Newspapers occasionally ran speculative pieces. Are we due for another visitor? Podcasts kept the story alive, blending updates on telescope surveys with musings about extraterrestrial contact. For once, science and culture shared the same rhythm, both leaning forward, both listening. It was a rare moment when humanity's attention turned collectively toward the same horizon. And so, as the years turned, the waiting itself became part of the story. Humanity stood at a threshold, aware that the galaxy was not silent, aware that fragments from other suns could cross our path at any time. The question was not whether the next would come, but whether we would recognize it, whether we would be ready to greet it with more than astonishment. The night sky, unchanged in its brilliance, now felt more alive, more filled with possibility. Stars still wheeled, planets still glowed, but in the silence between their familiar motions, people sensed the unseen paths of wanderers still on their way. And in that awareness, waiting became a form of reverence, a quiet acknowledgement that we are not alone in the river of the cosmos, that at any moment another messenger might appear, carrying with it not answers, but the gift of wonder. It happened on the first night of July 2025. The Atlas survey, automated terrestrial asteroid and lunar survey, was built to watch the sky like a tireless sentinel, scanning for objects that might one day collide with Earth. Its cameras swept broad swathes of the heavens, comparing new images against old, marking the faint motions of rocks and ice drifting across the solar system. Most nights were uneventful, the screens filled with the silent ballet of known asteroids tracing their ancient paths. But on this night, a point of light betrayed itself with a velocity far beyond expectation. At first it was a curiosity, flagged by software and confirmed by human eyes. The object moved faster than typical asteroids, faster even than many comets. Its angle was steep, cutting through the solar system like an arrow rather than circling in the familiar loops. As the data accumulated, excitement rose. Calculations fed into models refined into predictions, and the verdict came back unmistakable. The orbit was hyperbolic. Once again, the sun could not hold this traveller. Once again, the cosmos had delivered a messenger from beyond. This one would be named Through-Eye Atlas, in honour of the survey that had caught its fleeting light. Word spread quickly through the astronomical community. Emails and phone calls crossed continents, telescopes shifted their gaze, and within hours a network of instruments was tracking the new arrival. The tone was different this time, less disbelief, more urgency. Oumuamua had been too strange, Borisov too reassuring, but Atlas arrived into a world already waiting, already prepared to receive. The waiting years had trained scientists not to be caught unready. Within days, data flowed in torrents, observations piling into archives, spectra dissected for clues. The numbers astonished even seasoned researchers. Atlas tore through space at more than 130,000 miles per hour, a speed that defied easy analogies. Its path was uncanny, not only hyperbolic, but improbably precise in its near encounters. As models projected its trajectory backward, it appeared that the object had passed close by 3 planets, Jupiter, Mars, and Venus, its path weaving between them with the improbability of a needle threading 3 moving eyes. The odds, calculated soberly, were less than half of 1%, closer to the improbability of winning a lottery drawn across the span of the entire planet. And yet, there it was, its orbit traced in cold numbers. Astronomers leaned closer to their screens, shaking their heads in disbelief. Some muttered of coincidence, others of chaotic mechanics we did not yet grasp. A few whispered, almost reluctantly, that such precision looked intentional. For the public, once the news broke, it felt like a scene from myth, a cosmic traveller weaving its way through planets as though guided by unseen intelligence. The object's brightness added to the strangeness. Instead of flaring in predictable rhythm like Borisov, or dimming and brightening chaotically like Oumuamua, Atlas shone with a pattern that resisted explanation. Some nights it grew brighter as if unfolding mirrors, then dimmed as though folding again. Its surface reflected sunlight in ways that suggested either a highly unusual composition or something smoother, more regular, than natural bodies typically display. Telescopes captured only points of light, but within those points were whispers of geometry, hints that the object might be more than jagged rock. For those who had waited since Borisov, the discovery of Atlas carried both thrill and dread. Here was the 3rd visitor, the herald some had anticipated, the one that would either deepen the mystery or resolve it. And already it seemed stranger than Borisov, more deliberate in its path than Oumuamua. Scientists scrambled to measure, to record, to build a coherent story before it too slipped away. Engineers dusted off plans for fast intercept probes, though the window was short. Politicians were briefed, and for once they listened with uncharacteristic seriousness, sensing the public's hunger for answers. But beyond the institutions, ordinary people once again looked up. News outlets ran breathless reports. 3rd interstellar visitor detected. Artists rendered Atlas as a gleaming shard of ice, as a silver sail, as a machine half shattered by time. Forums and late-night shows debated its meaning. Was it another comet, merely strange but natural? Or was it what some had long suspected, evidence that we are not alone? Each new observation fed both camps, for the data was real but ambiguous, solid numbers cloaked in mystery. For astronomers who had been young graduate students during Oumuamua, the discovery of Atlas felt like destiny. They had grown up on its mystery, matured on Borisov's familiarity, and now, as seasoned researchers, they faced a visitor that combined both strangeness and reassurance in one. The sense of living through history was palpable. This was not just another comet, not just another paper to publish. It was an event that might shape how humanity thought of itself for generations. The sky that summer seemed charged with expectation. Telescopes turned night after night, following the new messenger as it carved its improbable path. Each photon collected was a fragment of its story, each graph a verse in a narrative still unfinished. And in the quiet of observatories, amid the hum of equipment and the glow of monitors, astronomers felt again the awe that had drawn them to the stars in the first place. Not the awe of solving puzzles, but the awe of confronting mysteries too large for answers. Atlas had arrived. And though it brought no voice, no signal, no clear sign of intention, its very presence was enough to stir humanity's imagination. For some, it was a comet like any other, wandering in from a distant system. For others, it was a probe disguised as stone, weaving deliberately between worlds. For everyone, it was a reminder that the universe is alive with motion, that the void is not empty, but a river flowing with travellers. And as the weeks passed, one truth became clear. This 3rd visitor would not fade quietly into memory. It had already woven itself into the fabric of our imagination, a symbol that stood at the threshold between coincidence and intention, between chance and design. Humanity once again was listening. Was. The orbit of Atlas was unlike anything that had been traced before. When the first models were plotted, scientists leaned over the diagrams with disbelief, as though the cosmos had played a trick on them. The path cut into the solar system at an angle steep enough to reveal its alien origin. But what astonished most was the way it threaded its course between worlds. Jupiter, the great guardian of our system with its immense gravity, lay in its path, and yet Atlas slipped past at a distance so exact it seemed almost chosen. Mars, the red wanderer that has always carried humanity's fascination, lay next, and once again the trajectory skimmed close before veering away. Finally, Venus, bright and veiled, passed near its arc. 3 encounters, each improbably precise, each brushing the edge of catastrophe but never touching. To calculate the odds was to court vertigo. Numbers poured into simulations, supercomputers ran scenarios, and the probability of such a sequence occurring by chance fell to a sliver, less than 1 in thousands. One scientist compared it to tossing a stone from a hilltop and watching it bounce perfectly through 3 narrow doorways in a row. Another said it was like threading a needle while blindfolded, the thread guided not by sight, but by some hidden hand. The metaphors spoke of awe, but also unease. For astronomers, the implication was double-edged. On one hand, gravitational mechanics can create surprises, and rare alignments do occur. On the other, the precision of Atlas's near encounters stirred a quiet murmur. What if this path was not random at all? No one declared it openly in the early papers, but in private conversations the question circled like a hawk. Could something have steered it? The public, once the details emerged, seized upon the imagery. Newspapers illustrated the orbit with glowing arcs weaving between planets, the object darting like a dancer through a cosmic maze. Commentators spoke of intention, of choreography, of a silent message written in motion. Artists rendered Atlas as a silver spear aimed perfectly through the corridors of the solar system, its precision both beautiful and unsettling. Even skeptics admitted that the trajectory was astonishing, a feat of celestial geometry that challenged the imagination. Within observatories, however, caution prevailed. Teams published papers suggesting chaotic gravitational influences, perhaps a scattering from unseen bodies in the outer dark. Some pointed to the possibility that Atlas had passed close to other stars in the distant past, its orbit shaped by forces we could not reconstruct. Yet none of these explanations fully satisfied, and each left gaps wide enough for speculation to slip through. And speculation flourished. In the quiet hours of the night, astronomers who had spent years staring at data allowed themselves to wonder. What if Atlas was more than a fragment? What if it had been aimed, nudged by forces or intentions beyond our grasp? The thought was dangerous, bordering on taboo, but it lingered like the aftertaste of a dream. Once spoken, even in whispers, it could not be unsaid. For ordinary listeners, the implications were profound. If Atlas had truly threaded its way through 3 planets, what did that mean? Was it scouting, measuring, mapping? Was it a coincidence amplified by our need for patterns, or was it a performance meant to be noticed? The questions spread across dinner tables, classrooms, late-night broadcasts. People who had never looked through a telescope now found themselves sketching its orbit on napkins, tracing the improbability with their fingers, marvelling at the possibility of design. The sense of choreography awakened deeper cultural echoes, myths of gods hurling spears, of messengers weaving through obstacles, of celestial signs guiding destiny. All seemed to resonate with the path of Atlas. The object became not just a piece of rock or ice, but a symbol layered with human meaning. For those who longed for reassurance, it was a reminder that perhaps we are part of a larger story. For those who feared the unknown, it was a warning that perhaps we are being watched. Among scientists, the debates grew sharper. Some insisted that to suggest intention was reckless, an abandonment of rigour. Others argued that the data itself demanded open-mindedness, that extraordinary trajectories required extraordinary consideration. Yet even those most resistant admitted, if only reluctantly, that Atlas was not ordinary. To study it was to confront the edges of understanding, where knowledge thins and mystery presses close. As telescopes continued to follow it, Atlas revealed more oddities. Its brightness shifted in irregular rhythms, suggesting surfaces that reflected light in ways inconsistent with dust or ice alone. Its mass seemed lower than expected for its size, as though it were less dense, more hollow, than natural bodies tend to be. Each clue added weight to the sense that this was not just another comet, and yet, with every anomaly, the scientific instinct for caution pushed back harder. To leap to conclusions was to risk error, but to dismiss the strangeness was to risk blindness. For the public, this tension was invisible. What mattered was the image, a visitor threading a needle between worlds, its passage improbable, its meaning uncertain. The narrative was irresistible. Atlas was no longer just 3I, the third interstellar object catalogued by humans. It was a herald, a performer on the stage of the solar system, leaving humanity to wonder whether it had danced for us alone. In the quiet hours of reflection, the trajectory of Atlas was more than mechanics. It was poetry written in motion, a path that seemed to speak in a language beyond words. Whether chance or design, it carried the same lesson, that the universe is capable of arrangements far beyond our comprehension, that even the cold mathematics of orbits can stir the heart with wonder. And so the improbable orbit of Atlas became the centre of fascination. Scientists argued, philosophers pondered, artists created, and ordinary people gazed upward with a mix of awe and unease. The question remained unanswered, suspended like the object itself in the sky. Was this choreography the work of chance, or the trace of intention? No answer came, only the silent arc of a visitor threading its way through our system, leaving us to fill the silence with our own stories. If the orbit of Atlas had unsettled astronomers, its surface only deepened the enigma. From the first days of observation, telescopes recorded fluctuations in brightness that resisted the usual explanations. Comets brighten predictably as they approach the sun, their ice vaporizing into jets that scatter sunlight. Asteroids, depending on their shapes and rotations, reveal light curves that can be modelled with precision. Atlas, however, played by neither set of rules. Its brightness rose in steps, plateaued, then dipped in sharp drops only to flare again without warning. The light curves resembled the jagged rhythm of an unfamiliar song, irregular yet oddly deliberate. Spectroscopic studies strained to interpret the signals. Some wavelengths suggested icy components, others hinted at metallic reflection. The ratios did not fit comfortably within known categories. For every data set that suggested ordinary cometary ice, another pointed towards surfaces too smooth, too reflective, as though polished. Astronomers accustomed to the comforting messiness of nature, craters, cracks, jagged ridges, now faced the possibility of an object with surfaces flat enough to glint like mirrors. The comparisons came quickly. Some likened it to shards of obsidian, volcanic glass that gleams unnaturally sharp against rough stone. Others imagined plates of metal, fractured but still gleaming after untold ages in the void. A few, whispering in cautious tones, noted how such reflectivity might be exactly what one would expect from a constructed sail or panel, designed to catch and redirect light. But science does not leap easily into metaphor. Papers proposed exotic ices invisible in their sublimation, or unusual layering caused by interstellar radiation. Perhaps cosmic rays had stripped Atlas's surface over eons, leaving a skin so smooth it reflected like polished stone. Perhaps impacts in its distant past had shattered and fused it into sheets, unlike anything in our own system. Each proposal tried to tether the data to natural processes, but none fit cleanly. It was as though Atlas had been assembled from multiple stories at once, each plausible in part, yet together incoherent. For the public, the strangeness of its reflection ignited imagination. Artists depicted Atlas as a fractured mirror drifting through space, its shards catching sunlight like a beacon. Others painted it as a great obsidian spear, glistening as it spun. Conspiracy forums buzzed with speculation. Was it a probe disguised as rock, its surfaces engineered to reflect signals invisible to us? Was it a derelict craft, broken yet still bearing the glimmer of its design? Even those uninterested in aliens found poetry in the idea. A mirror from another star drifting across the void, reflecting our own light back at us. What better metaphor for the way the cosmos reveals ourselves to ourselves? The irregular gleam of Atlas was not just data, it was a story waiting to be told. In observatories, the debate grew more pointed. Younger researchers, raised on the mystery of Oumuamua, pressed for open consideration of artificial hypotheses. Older colleagues urged restraint, reminding them of careers ruined by speculation. Yet the data remained stubborn, gleaming like the object itself, resisting neat explanation. Each spike in brightness was a prod, each dip a taunt, as though Atlas itself demanded we stretch our imagination. The irregular reflections also carried practical puzzles. If Atlas was indeed a cometary body, then its eruptions of gas should leave detectable tails of dust. Yet the tails, if they existed, were faint, almost ghostly. Some instruments caught hints of them, wisps dissolving into the dark, but nothing consistent. The brightness changes did not match the feeble emissions. It was like hearing a drum beat without seeing the drummer's hands, cause and effect uncoupled. The sense of design whispered again. A polished surface, thin and wide, might reflect light in bursts as it turned, brightening sharply when angled toward Earth, dimming when tilted away. Some curves in the data resembled just such a geometry. Was this coincidence, or evidence of something crafted? The answer remained elusive, but the suspicion lingered like a shadow no one could banish. In the public imagination, the mirror-like qualities of Atlas took on symbolic weight. Some called it the looking glass of the cosmos, a shard that reflected not only light but humanity's own longing. To gaze at it through telescopes was to see not just an object, but the reflection of our own questions. Who are we? Are we alone? Do others wander the stars, sending fragments or signals to test the silence? Atlas, gleaming unpredictably, offered no reply, only a shifting pattern of brightness, a riddle written in light. Philosophers took notice too. They spoke of the object as a metaphor for truth itself, partially revealed, partially hidden, changing as the angle shifts. One moment dazzling, the next obscure, it reminded us that knowledge is never static, that certainty is always provisional. Like a mirror that distorts depending on the light, Atlas forced humanity to confront the limits of its perception. Meanwhile, engineers dreamed. If Atlas was natural, it was a fragment from an alien world, bearing materials we had never touched. If it was artificial, it was proof that technology could survive the gulfs of time and distance, drifting intact for eons. In either case, the desire to intercept it grew urgent. Missions were proposed in feverish detail, fast-launch probes, solar sails of our own, even nuclear-powered craft capable of bursts of speed. But Atlas was already moving too fast, already too far. By the time blueprints became hardware, it would be gone. And so once again, humanity was left with light alone. Charts of brightness, spectra of reflections, curves and dips traced on graphs. These were the only fragments of Atlas that we could hold. But in those fragments lay a haunting message. The universe is not only stranger than we imagine, it is stranger than we can imagine. As the weeks passed, the irregular gleam of Atlas became part of its legend. Each flash and dip was a heartbeat, a rhythm that drew humanity into its mystery. Scientists measured, philosophers reflected, artists dreamed, and ordinary people gazed upward, knowing that somewhere in the night sky, a mirror from beyond was tumbling silently away, reflecting our own light back at us for a fleeting moment before it vanished forever. It was inevitable that Avilob would return to the conversation. He had been the loudest voice insisting that Oumuamua might be something more than rock and ice, and now, with Atlas gleaming irregularly and weaving improbably between planets, his arguments once dismissed as speculation found a new audience. In interviews, articles and lectures, he spoke with calm insistence. We should not fear the possibility that we are witnessing technology from elsewhere. To him, Atlas was not just another cometary body. It was another clue, perhaps even stronger than the first, that the galaxy is not silent. Low pointed to the improbable orbit, the reflective surfaces, the lack of predictable cometary emissions. He reminded listeners that if humanity could imagine light sails and probes drifting between the stars, so too could civilizations older and more advanced. The cosmos, he argued, is vast enough and ancient enough that our solar system could easily have been brushed by technologies from beyond. To dismiss the possibility outright was, in his view, a failure of curiosity. But beyond technical points, he also leaned into metaphor. He invoked the dark forest hypothesis, a concept popularized in science fiction but chilling in its implications. The universe, he suggested, may be like a dark forest, where each civilization is a hunter, silent and cautious, fearing discovery by others. In such a forest, the wisest strategy is to hide, to send only the faintest of scouts, disguised as fragments, drifting quietly to observe without revealing the presence of their makers. Atlas, with its silent passage and improbable trajectory, fit the role of such a scout uncomfortably well. The idea struck a chord with the public. The image of a dark forest filled with unseen watchers resonated with primal instincts. People imagined Atlas as a camouflage drone, a mechanical seed tossed into the void, drifting between stars in search of signs of life. Was it observing us? Was it relaying information back to an origin we could never locate? Or was it merely a relic, a derelict that once had purpose, but now wandered blindly, its mission long forgotten? The questions, unanswered, carried their own weight. Among scientists, reactions were as divided as before. Some bristled, accusing Loeb of dressing science fiction in the robes of astrophysics. Others, though still cautious, admitted that the anomalies of Atlas were difficult to dismiss. In seminars and private correspondence, younger researchers confessed that the artificial hypothesis, once ridiculed, no longer seemed absurd. Even if they did not believe it, they could not deny the tug of its plausibility. The controversy spilled again into headlines. Newspapers ran features with provocative titles: "Is Atlas an alien probe?" Television anchors raised their eyebrows over diagrams of its orbit. On social media, debates raged between skeptics and believers, each side quoting snippets of data, each side certain of its interpretation. For a moment, the world seemed to turn its collective gaze skyward, caught between wonder and unease. Yet beyond the noise, a quieter truth persisted. Atlas, whether artificial or natural, had already expanded our vision. By simply existing, it forced humanity to confront possibilities long relegated to fiction. It blurred the line between what we know and what we dare to imagine. In doing so, it reminded us that the cosmos is not a place of comfort, but of confrontation, with strangeness, with chance, with our own smallness. The dark forest metaphor also raised uncomfortable questions about how humanity should behave. If others were watching, should we remain silent, hiding our signals, our broadcasts, our presence? Or should we reach outward, announcing ourselves boldly to the void? The debate, once confined to theoretical circles, began to trickle into public discourse. For some, the thought of hiding felt cowardly, a betrayal of curiosity. For others, it felt prudent, even necessary, for what hunter reveals himself in a forest filled with predators? Atlas, silent and mysterious, became the mirror in which these anxieties reflected. Philosophers saw in this moment a turning point. The discovery of interstellar visitors had not only shifted astronomy, but had begun to reshape our self-perception. We were no longer the solitary centre of a quiet cosmos. We were beings in a forest whose darkness might conceal neighbours, some friendly, some indifferent, perhaps some dangerous. Whether Atlas was natural or not mattered less than the fact that it had reminded us of this reality. Loeb, for his part, did not waver. He spoke not with the urgency of fear, but with the calm of conviction. To him, openness was strength. To explore, to imagine, to admit possibilities. This was the essence of science. He acknowledged that Atlas might yet prove to be natural, but he urged that we prepare for the alternative. Better to be ready for wonder than to be blindsided by it. As the weeks passed, Atlas continued its silent flight, indifferent to debates on Earth. Its brightness flickered, its orbit carried it onward, its mystery remained. And humanity, once again, was left to fill the silence with meaning. For some, it was an ordinary comet, albeit unusual. For others, it was a disguised machine, a scout in the dark. For all, it was a reminder that the universe is vast enough to hold both truth and imagination in the same breath. In the quiet of night, when one lies awake beneath the stars, the thought of Atlas carries a peculiar hush. A fragment from elsewhere, weaving improbably between worlds, gleaming in irregular flashes. Was it chance, or was it choice? The forest remains dark, the watchers unseen, the questions unanswered. But perhaps that is the gift Atlas brings. Not certainty, but the wonder of not knowing, the sense that the story of the universe is still unfolding, and that we are part of its unfolding at last. Even as Avi Loeb's voice grew louder, the the weight of the scientific establishment pressed back with equal force. Agencies in the United States, in Europe, and in Asia responded swiftly, careful to keep the conversation tethered to familiar ground. To them, Atlas was extraordinary, yes, but not beyond the reach of natural law. The temptation to call it a probe, a messenger, a machine, was strong, but for most researchers the discipline of skepticism was stronger. At press briefings, scientists spoke with calm authority. They reminded the public that comets and asteroids can behave unpredictably, especially when drawn from environments our instruments have never studied directly. An interstellar fragment might carry chemistry unknown to our system, or ices that vaporize invisibly. Atlas's odd brightness fluctuations, they argued, could arise from jets hidden on its shaded side, or from patches of material reflecting sunlight in unusual ways. The improbable orbit, too, might be less improbable than it appeared, the result of gravitational nudges compounded over millions of years. What seemed choreographed could, with enough time and complexity, emerge from chaos alone. Papers appeared in journals, carefully worded, filled with models and simulations. One suggested Atlas might be composed partly of supervolatile ices, like carbon monoxide, which release gas without leaving bright tails. Another proposed that collisions long ago had reshaped it into fragments with unusually smooth surfaces, now tumbling in a way that mimicked artificial reflection. None of these explanations were perfect, but they were natural, and that, for many scientists, was reason enough to prefer them. The pushback was not only about evidence, but about credibility. To leap too quickly toward alien technology risked undermining trust in science itself. Agencies that funded telescopes and space missions needed the public to believe in their rigor, not their willingness to speculate. For every scientist who felt the pull of wonder, another felt the responsibility of restraint. They knew that once the idea of alien probes escaped into headlines, it would be nearly impossible to cage again. Better, they thought, to anchor the story in nature's strangeness than to let imagination run ahead of data. This tension was visible even within teams. In private meetings, some younger astronomers whispered their fascination with the anomalies, only to fall silent when senior colleagues cautioned against speaking such thoughts aloud. Careers were fragile, reputations more fragile still. The lesson of Oumuamua lingered. Speculation had brought fame to some, but it had also brought ridicule. Few wished to risk the latter. Still, the resistance was not merely defensive. For many, the beauty of science lay precisely in finding natural explanations for what at first seemed miraculous. The more bizarre Atlas appeared, the more determined they became to show that chaos and physics alone could sculpt such strangeness. There was pride in this, a kind of faith in nature's inventiveness. If an answer could be found without invoking intention, then science had once again proven its reach. Yet even the most cautious voices could not erase the unease. In interviews, when asked directly whether Atlas might be artificial, scientists often smiled thinly, choosing words with care. It is unlikely, they would say, or there is no need to invoke such explanations yet. Rarely did they say impossible. That small hesitation, barely perceptible, carried its own weight. The public noticed. To many, the official explanations felt too neat, too eager to close the door. People wondered whether scientists were protecting their reputations or protecting the truth. Online forums buzzed with suspicion. Why dismiss the anomalies so quickly? Why cling to improbable natural theories when the simplest explanation was at least worth considering? The skepticism of the scientific establishment, meant to calm, sometimes had the opposite effect, feeding speculation rather than ending it. Meanwhile, Atlas continued its indifferent journey. It neither confirmed nor denied the theories spun around it. Its light flickered, its orbit carried it onward, and with each passing week it became harder to observe. Telescopes strained to catch the faint signals, the data dwindling as the visitor slipped away. The debate, once rooted in observation, now tilted more heavily toward interpretation. Without fresh evidence, each side, cautious naturalists and bold speculators, spoke past each other, each convinced the other missed the deeper truth. For ordinary people watching from the sidelines, the tension itself became part of the drama. It was not only a question of what Atlas was, but of what science should be. Should it be bold, willing to risk error in pursuit of wonder? Or should it be cautious, protecting its integrity even at the cost of imagination? The debate over Atlas was, in this sense, a debate about humanity's relationship with the unknown. In classrooms and lecture halls, the lesson took on a quieter form. Professors reminded students that skepticism is the engine of progress, but also that every paradigm shift in history had begun as speculation. Galileo, Kepler, Darwin, all had once been accused of seeing too far. The balance between daring and discipline, between imagination and rigour, was never easy. Atlas, in its silence, had become a case study in that balance, a mirror reflecting both science's strengths and its limits. And in the evenings, when astronomers stepped outside their observatories, leaving behind the debates and graphs, they sometimes looked up at the stars with a different kind of awareness. Whether Atlas was natural or not, whether it was a shard of ice or a fragment of design, it had reminded them of something fundamental. The universe is vast enough to humble certainty. Skepticism may guard against error, but it does not erase mystery. The cosmos, indifferent to our debates, continues to move in silence, carrying secrets that may never be resolved. And so the skepticism persisted, strong and unyielding, a shield against unfounded leaps. But beneath it, curiosity still smouldered, refusing to be extinguished. For no matter how many papers were published, no matter how carefully natural explanations were offered, the memory of Atlas's improbable orbit and its irregular gleam remained, nagging like a half-remembered dream. Science, after all, thrives on questions, and Atlas had given us questions that no one could yet answer. As Atlas carved its way deeper into the solar system, the world's observatories responded with a rare unity of purpose. For once there was no competition for telescope time, no jealous guarding of data. The sense of urgency was too strong, the awareness too clear. This was history unfolding above our heads. If Oumuamua had slipped away too quickly and Borisov had reassured us with familiarity, Atlas demanded all eyes, all instruments, all patience. The Hubble Space Telescope, orbiting above the haze of Earth's atmosphere, turned its ancient mirrors toward the faint glimmer. Its instruments, designed to capture light older than humanity itself, now strained to read the signatures of a single traveller. Each photon that struck its detectors was precious, a clue in a puzzle written across light years. In crisp images, Atlas appeared no larger than a speck, yet its brightness, shifts and subtle colours carried whispers of composition. Teams on the ground worked long nights, analysing spectra, comparing them against catalogues, searching for anything that might match. Meanwhile, the James Webb Space Telescope, still new enough to feel like a miracle of engineering, joined the vigil. Its infrared eyes saw what Hubble could not: the faint warmth of gases, the subtle glow of ice sublimating into vapour. Webb revealed traces of carbon monoxide, faint but present, mingling with other molecules. The signals were inconsistent, sometimes flaring, sometimes vanishing, as though Atlas itself were breathing in irregular rhythms. To some, it looked like natural processes unfolding strangely. To others, it resembled systems turning on and off, like a machine cycling through states. On Earth, observatories from Chile's Atacama Desert to Spain's Canary Islands, from South Africa to Hawaii contributed their gaze. The night skies of the southern hemisphere offered especially sharp views, dry air and high altitudes allowing instruments to catch what northern telescopes might miss. Astronomers coordinated like musicians in an orchestra, each playing a part in a symphony of observation. They tracked its tumbling motion, its orbit, its fleeting emissions, pooling data into archives accessible worldwide. For once, science felt like a collective ritual, humanity's global eyes lifted toward the same mystery. What struck many observers was not only the data, but the feeling. To watch Atlas was to participate in something larger than research. It was to feel the shared weight of being human beneath a sky that suddenly felt closer. Nations divided by politics shared information freely. Amateur astronomers uploaded their images to online forums, their modest telescopes capturing faint streaks that complemented the great observatories. Children in classrooms traced the orbit on chalkboards, their teachers explaining that they were alive in a time when the universe itself had sent visitors. The sense of vigil spread beyond astronomy. News outlets tracked the story daily, offering updates like weather reports. Atlas brightens unexpectedly, one headline declared. Trajectory passes third planet, another read. People followed the saga as they might follow the passage of a comet or the unfolding of an eclipse. There was wonder in the awareness that at that very moment, above their rooftops and cities, a fragment from beyond the stars was passing through, and the whole planet was watching together. For many, this was the most moving aspect. the unity of gaze. In an age where division seemed endless, Atlas reminded humanity that there was still something universal, something that belonged to no single nation or creed. The stars had no borders, and neither did wonder. To follow Atlas was to remember that we are, all of us, dwellers on the same fragile world, orbiting together beneath a sky that does not care for our divisions. Yet even as telescopes gathered their data, the mystery deepened. The brightness shifts recorded by Hubble and Webb refused easy explanation. The chemical signatures wavered, unstable, as though the object was cloaked in processes unfamiliar. Its orbit, refined by constant observation, still traced the improbable thread between planets. The more humanity looked, the more questions multiplied. It was as if Atlas, knowing it was watched, chose to remain ambiguous, a performer in a play whose script was written in riddles. Among astronomers, the tension between skepticism and speculation sharpened. Teams analysed the Webb data with meticulous care, parsing every fluctuation. Was it simply a body shedding gases irregularly, fractured by impacts long ago? Or were we seeing hints of something stranger, patterns too sharp to be coincidence? Conferences buzzed with presentations, some sober and cautious, others daring to suggest possibilities beyond the natural. The debate spilled into the public sphere once more, drawing both fascination and fatigue. But in quiet moments, the raw experience overshadowed the arguments. Astronomers described stepping outside after long nights at the console, looking up at the unassuming point of light and feeling tears prick their eyes. Not because they believed it was alien, not because they feared or hoped for contact, but because they felt part of something vast. To stand on Earth and know that you are witnessing a piece of another star system passing overhead is to feel the fragile miracle of being alive in this moment of cosmic time. As weeks stretched into months, the vigil continued. Atlas moved steadily across the sky, slower now relative to Earth, but still impossibly fast by human measures. Data continued to pour in, the archive swelling with light curves and spectra, models and simulations. Each entry was a small act of devotion, a testament to humanity's refusal to let this messenger pass unnoticed. In the end, the global vigil may have mattered as much as the data itself. For while the scientists sought answers, ordinary people sought connection. To know that telescopes in deserts and mountains, satellites in orbit, and even backyard astronomers were all watching the same point of light was to feel, briefly, united. Atlas was not just an object. It was an event, a shared memory written into the fabric of our time. And when, inevitably, it would slip into darkness and vanish like its predecessors, that memory would remain, of nights when humanity turned its gaze together, waiting, watching, wondering what story the stars were telling. As Atlas's light flickered in irregular rhythms, another layer of speculation began to unfold. Not about machines or sails, but about seeds. For decades, some scientists had entertained the idea of panspermia, that life is not confined to the planets where it emerges, but is carried through space, scattered like pollen on the galactic wind. Atlas, with its alien chemistry and ancient journey, seemed to many the perfect emblem of this possibility. The concept is older than modern astronomy. In ancient Greece, Anaxagoras had spoken of seeds of life scattered across the cosmos, drifting invisibly until they found fertile soil. In Indian texts, too, stories described sparks of being carried on the winds of heaven. These myths, born of imagination, found unexpected resonance centuries later in science, when researchers discovered hardy bacteria that could survive the vacuum of space, spores resistant to radiation and freezing cold. If such organisms could endure, then perhaps comets and interstellar fragments were not lifeless at all, but couriers of potential, bearing the building blocks of life across impossible distances. Atlas seemed to embody this role. Its faint emissions contained carbon compounds, cyanide, water ice, molecules familiar to biologists as the scaffolding of life. Observers imagined it passing by other systems in ages past, perhaps shedding fragments, perhaps depositing dust rich with organics onto alien worlds. Had it been a seed long ago, cast from the cradle of another star? Or was it itself seeded during its wanderings, carrying hitchhikers that might one day find a home? The notion captured the public imagination. Articles spoke of Atlas as a gardener of the galaxy, sprinkling the ingredients of life wherever gravity and chance allowed. Poets described it as a dandelion puff drifting through eternity, each mote a possibility of worlds to come. Teachers explained it to children as a cosmic bee, moving from flower to flower across the stars, unknowingly spreading the potential for bloom. The metaphors multiplied, each softer, gentler than the talk of probes and scouts, yet no less profound. For scientists, the hypothesis was both thrilling and humbling. If life could spread in this way, then Earth was not isolated but part of a network, a node in a web of a living possibility. Perhaps our own beginnings owed themselves to such a visitor, a fragment that fell into the primordial seas billions of years ago, carrying molecules that sparked into cells. To consider this was to shift perspective, from seeing life as an accident of Earth to seeing it as part of a cosmic continuum seeded and reseeded across time. But panspermia raised questions as haunting as they were beautiful. If life travels on stones like Atlas, how far can it truly go? Does it perish in the void, or does it endure, dormant until the right planet offers warmth and water? And if such seeds are common, then why does the galaxy not bloom more visibly with civilizations? The silence of the stars pressed against the hope of abundance, leaving only the mystery of balance between possibility and rarity. Some philosophers suggested that panspermia does not solve the question of origins but shifts it. If life came to Earth from elsewhere, where did it first arise? Was there a single cradle, a first world from which all life in the galaxy descends? Or are there countless cradles, each sending out their seeds, mingling in the darkness, crossing and recrossing like invisible rivers? In either case, the idea was profound, that every breath we take might carry within it atoms once touched by alien soil, that our very existence might be the echo of journeys like Atlas's. The imagery was not lost on the public. People imagined Atlas not as a cold rock, but as a vessel of possibility. Its irregular brightness became a heartbeat, its trajectory a story of migration. It was no longer only a visitor, it was a gardener, a courier, perhaps even an ancestor. To contemplate it was to feel kinship with the cosmos, to sense that our roots might stretch not only into Earth's soil, but into the dust of 1,000 distant worlds. And yet, as always, caution whispered. No evidence proved Atlas carried life. No spores or cells could be detected across such distances. The molecules observed were simple, precursors at best, ingredients rather than recipes. To call it a seed was metaphor, not conclusion. But even skeptics admitted the metaphor had power. It made the public care, it made students dream, it made people look up at the night sky and wonder. Sometimes they conceded inspiration is as important as evidence. The debate spilled into wider reflections about humanity's future. If life can travel naturally between stars, then perhaps so can we. Our spacecraft, crude though they are, might be the first steps in a process that life has practiced for eons. Just as spores ride winds, perhaps civilizations ride rockets, continuing the same story at a higher octave. In this sense, Atlas was not only a reminder of the past, but a symbol of what might come, a reflection of journeys we ourselves may one day undertake. In bedtime quiet, the idea of panspermia takes on a soothing quality. To imagine that life is not fragile or solitary, but abundant and persistent, carried on the breath of stars, is to feel less alone. To imagine that the atoms within us were once part of a traveller like Atlas, drifting through gulfs of silence, is to sense continuity larger than our own lives. It is a comfort, a lullaby sung not by voices but by the whisper of molecules across eternity. As Atlas moved farther away, its light dimming into the background of the sky, this idea remained. Perhaps it was only rock and ice, perhaps it was more. But the thought that such travellers may have carried the beginnings of life itself, that was a seed planted not in soil but in imagination, and like all seeds, once planted it grows. By the time Atlas had grown faint in the telescopes, the debates and the data had already outpaced its fading light. Scientists continued their careful modelling, skeptics pressed their natural explanations, and dreamers leaned toward wonder. But beyond the technical arguments, a larger question began to echo. If these travellers are messengers, then what message do they bring? It is tempting to imagine the message as intentional, as if some distant mind had carved a script into stone and set it adrift toward us. Yet the truth may be subtler. The message may not lie in design, but in presence. To simply exist, to pass through our skies, to reveal that fragments of other stars can reach us. That alone carries meaning. It tells us that the cosmos is not closed, that our solar system is part of a greater web of exchange. Every interstellar visitor is a whisper of connection, a reminder that we are not as isolated as we once believed. For some, the message of Oumuamua was mystery. It said, "The universe still knows how to astonish you." For Borisov, the message was reassurance. The rules you know still apply. For Atlas, the message felt more complex, part enigma, part omen. Its improbable orbit suggested precision, its reflective gleam suggested ambiguity, its chemistry suggested possibility. It seemed to say, there are patterns you do not yet see, and stories you have not yet heard. Philosophers seized upon this ambiguity. One wrote that Atlas was like a poem whose lines are scattered, leaving the reader to piece together meaning. Another compared it to a stranger passing on a road, offering only a glance, neither invitation nor threat, but enough to change the traveller who saw it. Perhaps, they argued, the message is not about the object at all, but about us. How we respond reveals who we are. Do we ridicule or imagine? Do we close the door or open it wider? In that sense, the messengers from the stars are mirrors, reflecting not only light but our own posture toward the unknown. In quiet circles, spiritual interpretations also bloomed. Some saw Atlas as a sign of destiny, a symbol that humanity is being nudged toward a larger awareness. Others interpreted its silence as a challenge. The universe will not hand you answers, you must seek them yourselves. Ancient traditions were revisited. The star omens of Babylon, the comet prophecies of medieval Europe, the myths of messengers descending from the heavens. Atlas, though explained in scientific terms, carried an archetypal weight that touched something older than data. For the public, the message was often framed in simpler terms. We are not alone. Not necessarily in the sense of other civilizations, but in the sense of belonging to a cosmos alive with movement and exchange. The idea that fragments can cross the gulfs, that seeds or signals may drift between stars, transforms loneliness into kinship. Even if Atlas was only rock and ice, it had travelled across interstellar space, touched by suns we've never seen. To watch it pass was to feel the brush of distant worlds against our own. In classrooms, teachers turned Atlas into a parable. They told students that sometimes the most important message is not an answer but a question. They explained that science grows not from certainty but from mystery, that wonder itself is a form of knowledge, and in bedtime stories parents described Atlas as a visitor who came to remind us that the universe is larger than our fears and richer than our hopes. The message also contained a warning. If visitors can arrive unexpectedly, then so too can dangers. A fragment too large, a trajectory too close, could spell catastrophe. The same paths that carry seeds and symbols can also carry destruction. Atlas, threading so near to planets, reminded us of our fragility. The cosmos is not cruel, but it is indifferent, and in that indifference lies both gift and threat. To read the message is to recognize our responsibility, to prepare, to watch, to learn. Yet perhaps the deepest message was humility. In the rush of our daily lives, it is easy to imagine ourselves as central, our world as the axis around which everything turns. But Atlas, silent and swift, reminded us that we are not the authors of the universe, only readers of its passing script. Our place is small, our knowledge partial, our control limited, and yet, in our smallness, we are gifted with awareness, the ability to notice, to wonder, to assign meaning. That awareness may be the truest response we can offer to the messengers who pass. In the stillness of night, lying beneath stars, one might hear the message not as words but as a feeling, a sense that the universe is alive with currents unseen, a sense that our story is woven into a fabric larger than we can comprehend, a sense that each interstellar visitor, whether shard or sail, carries with it an invitation to remain curious, to remain open, to remain awake beneath the canopy of mystery. And so Atlas's message, like those before it, remained ambiguous yet profound. It spoke of connection and of caution, of possibility and of humility. It spoke not in sentences but in silences, not in symbols but in trajectories. And in its silence we found our own voices, asking questions that may never be answered, yet are worth asking nonetheless. Perhaps that is the true purpose of such messengers, not to tell us what to believe, but to remind us that the universe is still speaking, still unfolding, still inviting us to listen. By the time Atlas slipped into the cold distances, its light too faint even for the most powerful telescopes, the story of 3 interstellar visitors had become part of humanity's memory. Oumuamua, Borisov, Atlas. 3 names inscribed not in stone or parchment, but in orbits and light curves, in debates and dreams. They came without warning, stayed only briefly, and departed without farewell. Yet in their silence they left us altered, as though the sky itself had opened a door and shown us that we are not as alone as we once believed. Looking back, the sequence feels almost like a narrative, a trilogy written across the stars. The first came as a riddle, a shape without precedent, a motion that defied our categories. It whispered, "You do not yet know what is possible." The second came as reassurance, a comet clothed in the familiar, reminding us that the rules still hold. It whispered, "You are not mistaken, the galaxy is full of fragments like me." And then the third came, stranger again, threading a path of improbable precision, gleaming with surfaces that unsettled our models. It whispered, "Look deeper, the story is not finished." Perhaps these whispers are only echoes of our own minds, meaning imposed upon randomness. But even if so, the effect is real. For in listening, we remembered what it means to wonder. In debating, we remembered what it means to imagine. In disagreeing, we remembered what it means to care enough about the universe to argue over its mysteries. And that in itself is a kind of message. The 3 visitors also reminded us of time, how vast it is, how small our share of it may be. Each object had travelled for millions, perhaps billions, of years before arriving in our sky. During that journey, civilizations may have risen and fallen, stars may have flared and died, galaxies may have collided in distant silence. And yet, across all that, the fragment endured long enough to brush against our awareness. To think of this is to feel both insignificant and miraculous. Insignificant in the scale of things, miraculous in the chance that we were alive at the precise moment to notice. For the scientific community, the trilogy was a call to readiness. New surveys were funded, new telescopes planned, new missions proposed to chase the next visitor. We had learned that the galaxy sends more than light. It sends messengers, fragments that carry within them the potential to transform our understanding. To miss them would be to miss opportunities larger than lifetimes. And so, humanity began to prepare, determined that when the 4th visitor comes, we will not simply watch it fade but reach out to meet it. For philosophers and poets, the visitors became symbols. They spoke of cosmic kinship, of seeds drifting between stars, of scouts moving through a dark forest, of mirrors reflecting our own longings. The stories multiplied, each culture layering its own myths onto the silent travellers. Some saw warnings, others promises. Some saw the hand of chance, others the trace of intention. But all saw meaning, for meaning is what humans cannot help but weave. For ordinary people, the visitors became part of conversation, part of memory. They were spoken of around dinner tables, taught in schools, whispered in bedtime stories. Children who watch their parents trace the path of Atlas may grow old before the next arrives, yet they will remember the nights when the world turned its gaze together, and perhaps, in remembering, they will teach their own children to keep looking upward. What is the true legacy of Oumuamua, Borisov, and Atlas? Not answers, not certainty, but awareness. Awareness that the universe is alive with movement. Awareness that the gulf between stars is not absolute. Awareness that we are part of a cosmos still capable of surprise. And awareness, most of all, that questions matter as much as answers, for it is the questions that keep us awake beneath the stars. In the quiet of night, when one lies listening to the rhythm of breath and the murmur of the world outside, the thought of these visitors becomes like a lullaby. They remind us that we are small, but not forgotten, fragile, but not isolated. They remind us that to exist at all is to be part of something vaster than imagination, and that even in our smallness we can notice, we can wonder, we can care. And so the trilogy closes, not with a final revelation, but with an open door. The 4th visitor will come, tomorrow, or in a decade, or in a century. It may be familiar, it may be stranger still. Perhaps it will confirm what we already know. Perhaps it will overturn everything we believe. but when it comes we will remember the first three and we will be ready. Until then, the night sky is no longer merely backdrop. It is a stage upon which the universe occasionally sends its messengers, brief actors in a play larger than we can write. Our role is not to control the script, but to watch, to listen, to wonder. And in that role, there is dignity, there is meaning, there is peace. So let us keep looking upward. Let us keep the vigil. Let us keep alive the quiet flame of curiosity that makes us human. For the cosmos is not silent. It speaks in fragments, in orbits, in whispers of light. And if we are still, if we are attentive, we may yet hear the next message carried across the darkness. And perhaps in listening we will discover that the true message has always been this, that we are part of a story still unfolding, written not in words, but in stars.